Hello, my name is Juan Camacho. I'm a PhD student at the Department of Earth and Environmental Science. My poster's title is Convective Storms and Runoff Generation in a Highly Altered Urban Center of North Central Texas, USA, from Observations to Modeling. My research questions are: what are the main factors influencing stable isotope variations and precipitations in North Texas? What are the predominant urban water sources involved in stream flow generation during extreme precipitation events? And finally, how these extreme precipitation events can be a pollution driver in urban streams where different water sources are mixed during peak flow and base flow recession. The hypotheses are like these extreme precipitation events can significantly affect the hydrological response of urban streams, and storm runoff from mixed water from unknown urban sources can substantially affect the water quality in the stream. Also, the rapid mobilization and subsequent redistribution of hazardous pollutants during periods of heavy precipitation or flooding are expected to influence the water and environmental quality of the urban stream as sediment deposition into the stream increases. The study site is Rush Creek watershed in the city of Arlington, located in the DFW area. This watershed is mainly composed by residential parcels, which is about 49%. Also, you have infrastructure and industry as well as parking lots, which compose 31.6%. And finally, we have parks and vacant parcels comprise 9.5 and 9.8 respectively. Our methodology is based on precipitation and stream water sampling collection from event basins for precipitation events. We also use high-split modeling and discharge measurements. Then we use the laser spectrometry to analyze water-stable isotopes and develop variation mixing models. Also, we are measuring water quality data to develop concentration discharge curves, as well as collecting high-frequency images from gauge count system in the stream. From the results, we have that moisture sources from Arctic and Northern cold fronts and the Gulf of Mexico and the westerlies play a remarkable role in controlling the isotopic variation in north central Texas. We can see that during the summer, most of the moisture sources comes from the Gulf of Mexico. During the winter, the moisture sources come from the Pacific, from higher latitudes, and some from the Gulf of Mexico. During the spring, we have Gulf of Mexico and higher latitudes. And during fall, we have a good influence from the westerlies and the Gulf of Mexico. Here we can see in this dual plot the seasonality of the isotopic composition, with depleted values during winter time and enriched values during summertime. The isotopic compositions varies between 4.72 and minus 21.47. And we have different types of precipitation such as thunderstorms and convective rainfall. Also, the stream response is governed by convective storms, and the excess and isotopic composition suggest different sources from urban settings in the stream during peak flow events. Variation mixing analysis reflect that most of the water comes from precipitation. We have a small amount of base flow and irrigation tap water. We recorded 14 events during these 2 years, and we can see that tap water is between 12 and 23% of water in the stream. For the first event, for example, was recorded in August 2022, 55% of the water was water from precipitation via storm runoff. The second event was recorded in November 2023 with a contribution of 56% from new water from precipitation and 17% from irrigation tap water. And the last event was recorded in February 2024 with storm runoff contributing to 84% of new water into the stream. Also, we have water quality data and we analyze one event. So we should expect to see mobilization, which is the increase of concentrations caused by the increment of sediments into the system or into the stream. So we can see here that TOC, tannin and lignite, as well as phosphate increases with peak flow. You can also see here dilution and chemostasis. Dilution was recorded for dissolved iron, so the concentration decreases with the stream flow increases, and chemostasis, which means that nitrate concentrations remain constant. These are the different colors from the stream. As conclusions, we have that large precipitation events affects Rush Creek flashy hydrological response. However, variation mixing suggests different inputs from unknown urban sources. Also, phosphate, TOC, turbidity, and tannic lignin concentrations increase during storm events, suggesting an important sediment transport into the urban stream. As a future research, we plan to study temporal variations in water surface using tracer aid modeling to understand Rush Creek's hydrological behavior. And finally, we plan to use high-frequency images and couple it with water quality data to develop machine learning models able to predict water quality. Thank you.